Gentlemen, welcome back to the shop, or rather, welcome back to the design vid for the flashlight. I am stoked about this. First and foremost, I'm overwhelmed, and I think it's awesome that you guys are into what I'm doing, and even more so, it's absolutely amazing that people from all over the world can get together and enjoy some technical details and have a few laughs while we do it. And I'm really quite pleased that you're joining me here, where we pared down the do-it-all know-nothings. And we got about 600-700 guys here. It's nice to be able to do this because the trolls and the naysayers all get stuck on the outside to freeze their asses off, rather than enjoy the keg of beer that everybody chipped in on, and all they did was brought their solo cup and expect the world to bend over backwards for them. So, and the noise to signal ratio is a lot better as well. But mainly for me, I'm really out of my comfort zone, sticking my neck out here to design something on the fly and have it open for the world to critique. It's not an easy thing for me to get my head around. But as they say, horses for courses. This flashlight's going to be completely different, and that is the main design criteria. So if there's 10 or 20 guys that are on the entire planet that are interested in a you-build, do-it-yourself, completely modular kit, then I'm more than happy to share the process of engineering and design for small-scale manufacturing. And by small scale, I mean microscopic. Now, I know you guys really enjoy most of the regular vids. Sometimes I put out a stinker, but you know, you can't hit a home run every time. And it's very humbling to me that you like them so much that you're willing to throw a couple bucks as a thank you, but to share it even with the people who aren't contributing, who aren't pulling the cart. It's really amazing what we can do on aggregate. Like, I see the numbers creeping up there, and there's guys throwing 10 bucks in, there's guys throwing a buck in. It makes a huge difference. Anyway, enough of me getting all soft on you. Pitter patter, let's get at her. Now, when I floated this idea to you guys, I got some excellent feedback. I took it all to heart. And so, here are the design criteria. Bearing in mind that I'm old enough to know you cannot please everyone, so there's no point in even trying. It's going to be square. It's going to have a warm LED cob. 75 watts. Is going to get hotter than a $2 pistol. To mitigate that, we are going to go with evaporative cooling. Yes, this thing is going to have water in it. It's also going to be waterproof. I'm going to seal it up like I'd seal a hydraulic cylinder. So it should be able to take 3,000 psi. That's not quite the Marianas Trench, but it's about 2 kilometers. Because 1,100 fathoms. It's going to have lithium ion cells, 4 of them. Now, why 4? 1, lots of power. 2, we'll be able to jumpstart a D11 with it. Now, because this is going to be sealed up like a hydraulic cylinder, essentially, not going to be able to have any switches. So there's not going to be any rubber clicky-clacky switches. We're going to use a special little trick in order to get the inputs. Now, a lot of guys said that cycling through the strobe and the different functions is a pain in the ass. So we're going to eschew that. We're going to have direct inputs. Initially, there's going to be 2 programmable inputs. You can set it up for whatever you want. It's going to be a modular kit, a you-build kit. We're going to offer the control electronics and all that inward stuff, and we're going to offer the case. Unfinished, machined, of course, but unfinished, and you can decorate it however you want. If you want to burnish it, polish it, anodize it, whatever you want. Now, I use some open source software, but I'm not big on claiming open source, because then you got to pander to the open source crowd. But the drawings are going to be available. It's going to be a kit. We're also going to design it so that later on we can add modules to it. As I said, we'll have a module for jumping your car. Because it's going to be a super skookum shit brick house, and we'll design future bolt outs for GoPro cameras so you can jam them under water or spelunking or whatever. So like I said, completely different than anything out there. Because if you want the same old thing, just buy a mass-produced one. Case closed. And we're not constrained to design this for a whole bunch of sales. I don't give a shit. I just want to make something super skookum and cool to me. If anybody else wants to come along for the ride, that's fucking awesome. Sold as a kit, programmable, and that way we can do some vids about putting it together, and I think it's going to be a lot of fun. Okay, finally some fun stuff. We're down in the shop. We're going to do we're doing the mise en place, and here's the 140 Canadian pesos worth of aluminium. It's not even, I need the half-inch wall, but I just got the 3/8. So allowances have to be made for that. And then here's the half-inch front and back plates. Unfortunately, they didn't have any flat bar. So they just sheared it. And of course shearing, now she's got a list to the port. About as straight as a dog hind leg. So we'll stick her in the vise there, 2-ton vise, and see if we can't get that twist out of her. So I have no idea if this is going to work or not, but I don't think it'll hurt. I just got some neodymium magnets holding some big bolts here on the way that it's hogged. The high side here, and then we'll squeeze it down and move it along, inch it along, and see if we can't get the wow out of it. There you can see, doesn't take much. It's only 2 tons and I'm not even reefing on it, so it's maybe 1 ton. Okay, so that's a lot better there. And we'll hack off a 4-inch chunk and then square it up in the milling machine. Wish me luck here, boys. I'm going to lop off this chunk of aluminium with the cold cut saw, which is not a big deal in and of itself. But when you do all your work after hours in your own garage and you got a 2-year-old daughter, sometimes the missus gets a little owly. Sometimes it is easier to beg forgiveness than to ask for permission. Now, I filmed the entire design process. Unfortunately, it's too boring for words. So in the next video for you guys, we're going to finish building the prototype and you will get to see the basic design of it. Very industrial. Hey, I appreciate your help. Couldn't do it without you. Thanks for sharing a laugh and keep your stick on the ice. Hey, welcome back to the shop. We're doing the second prototype of the flashlight body today. As you can see, I'm already ahead of myself. I put the layout die on there and yeah, I haven't squared up anything up yet. So we're mainly going to be using the Bridgeport milling machine today. We'll also use the little box for delay there just for doing O-ring grooves. As you can see, the vise isn't installed. I just learned a trick from Pierre Baudry, who's actually a Quebecois machinist. I assume he's Quebecois with a name like Baudry. So I'm going to go ahead and show you his trick and see if I can get it right the first time. And basically, anytime you take the vise off or move it or whatever, you got to square it up so that you know when you put your piece in and you clamp it and you mill it that it's going to be square. So first off is to clean off all the surfaces, the mating surfaces, the bottom of the vise and the mill table. Here's the hardest part of the whole operation. Here's getting the vise up onto the deck. You either want a buddy with big arms and a little head, or maybe ask your wife to help you out. Oh God! Okay, that's the hard part done. Now we got the vise up there half-ass centered. We use these T-slut nuts. Slide in the T-slut and bolt her down. So what we actually got to do here is make sure we'll put a dial indicator on here, and then we'll tram this to and fro to make sure that it's perfectly square. And that way when we clamp a piece down and we machine it, we know it's perfectly square. Okay, so this is where Pierre's trick comes in. You get yourself a piece of ground flat stock here, and this is tool steel. The broken dreams of projects past. And now I'm going to tighten this one down. Just snug it down so it pivots. And the other side is loose, the other bolt is loose. We just give that a little tap with something soft. We'll snug this one down a little bit. Bring the quill back up. Okay, now we got the dial indicator. Okay, so I just got the dial indicator and a collet there. Now we're going to see how close we got it. Zero this. And then run the X. Way off. Way off. Just quickly, the trick is tighten down one side, leave the other side loose. That's your pivot. And then you can just move the bar back and forth. Okay, let's see how that worked. That was one. I think we're right on the money. What was that, 5 tries? It's a lot more better than the usual 15. Now, while I have this comically oversized shell mill in the mill, we're going to square up this square tubing. Man, that's pretty. I could do that all day. Of course, then it'd be a job. I'd probably get pretty sick of it. Want to brush my teeth with a 12 gauge. I enjoy making onesies, twosies of things. I don't know about sitting at a machine changing pallets. Doesn't seem like much fun. So I got the front and back plates squared on 2 sides. We're gonna gang them up here in the vise, and then we'll square them up on all 4 sides. I just got a little piece of soft aluminum filler rod, TIG filler rod. We're going to put that in the vise as well, and that'll take up any differences in the size. That'll allow us to gang drill this, because if we just clamped it in hard steel here, it'd only clamp on one of these and the other 2 would be moving all over the place. We don't want that. I'm going to come in with the 3/4 4 flute. Mainly that's what I brung, so that's what I'm going to run. I've been asked a few times to show how to run this thing, like conventional milling and climb milling, this, that, the other thing. I gotta say, this machine is completely clapped out. You do not do any climb milling on this, because what happens is it self-feeds, right? Yeah, the whole table will tweak over, take up the whole slop. This will break off. It's a bloody disaster. And further to that, I am not the guy you want to learn machining from. I am the guy who you want to laugh at after you've learned machining. Sad but true. Check out Tubal Cain, Mr. Pete 222, if you're interested in doing or learning about running a Bridgeport milling machine. I got the bottom plate bolt holes all laid out. That's the simplest part. I'm going to start with this one. And the bolt holes are all the same, so we're going to gang drill them. Going to use my Starrett automatic center punch. Beautiful tool. Wife gave me this a few Christmases ago. You always ask what I want for Christmas. I'm so hard to buy for, apparently. Anything with a Starrett on it is fine by me. You always ask me if I don't get bored of tools. Like maybe I want a shirt or a tie or something. Thing is about getting a beautiful tool for a gift, you have it forever. And then I remember the lovely Christmas when I opened up my Starrett number 18C automatic center punch. And you gentlemen have seen my machining. I need as big a target as possible. So I go over the automatic, give her a good whacking with the hammer. Now, conventional wisdom dictates that the lathe is the king of machine tools. I will tell you this, I use this milling machine about 10 times more often than I use my little lathe. However, having said that, if you only have access to one machine, a lathe is what you want, because you can reverse a whole bunch of stuff and sort of use it as a half-ass milling machine. So this is my second kick at the can at this, and I don't want to mess it up, so I'm using a little spotting drill or a centering drill just to get that hole started in a perfect right spot. This is a lot more rigid than a typical twist drill. We're going to run this, and then we'll run the standard twist drill. Oh, just about to pull the trigger. Got her all located with manual DRO. That is the laser highball. And look at that, the curse of having a cheap vise. What you want is one of those beautiful $1,000 Kurt vices that is worth more than the Bridgeport. It pushes the jaw down so the workpiece doesn't flip up. You can see here, this jaw tweaks up and the uppermost workpieces whoop, lifted up on us. Here we got them all packed. You see what I did wrong there? Son of a diddly. No spacer. So I can't drill all the way through, otherwise I'll ruin my vise. So that means I gotta drill down into this one, but not too far. And then I'll take these two off and reposition the yada yada yada. It just doesn't end. Man, I love having a milling machine. Yeah, that's gonna look awesome. We're just gonna countersink those so that the socket head screws are nice and flat. 21/64. I don't know if that's right. It should be 5/16. Yeah. Shit. I'm going to Grizzly Tools there in a little bit, so I'll pick one up then. In the meantime, I'll just deburr those holes. It's getting late here. This clock is correct twice per day. I got a feeling it's quite a bit later than that. But we got a goodly pile of shrapnel there for an after supper evening's work. But before I go upstairs and get cleaned up and crawl into bed, I'm going to clean these two parts off, glue them together, and I'll be able to handle this and dick around a little bit more and drill the holes good and proper. Beauty. Ça fit comme le gant d'O.J. Simpson. Now, thanks a lot for watching. We'll catch you tomorrow or whenever I finish this up. I don't know if it'll be a full vid or half. Anyway, keep your stick on the ice. Sorry, I'm back. I'm stoked. So here's the back section. This is the body with the guts. Here's the front section, the lens mounting and all that stuff, and the heat sink. This is all that. And then here's the evaporative cooling manifold. I might need to find a D11 to run this over, just for shits and giggles.
Gentlemen, welcome back to the shop. As you can see, today we are working on the flashlight. At least finish up the preliminary machining so that we can get the light in there and burn our retinas clean out of our heads. Just witness marking that, or no, that's transfer punching. I got her all marked. We can get rid of the glue. We put it in boiling water, or our old friend Terry the Torch.
It's just pie.
I get the spotting drill in there just because I don't want the drill bit to walk off at all, so I'm gonna take the time to spot drill it. Probably not necessary, but another one buys a duster. Now we're going 29 for 832. That's about 4 degrees metrique for you metrique fans. So we'll set the stop here so as not to go too deep. I'm being pretty ginger with that hunting and pecking there in and out because I don't want it to scour the hole. Those 832 threads are pretty small, eh? Yeah, a little bit of a stumble at the start gate. I don't have an 832 tap. So even though the hole is 6 thou oversize, we're gonna go with 4 millimeter. Looks like somebody's already been in here. Not pointing any fingers, but that looks like something I'd do. On the bright side, I do have a starting tap. So we're going to power tap that. That didn't look too good. It looks like it stripped it out. Instead of the starting tap, we'll start with the plug tap. Starting tap was probably a bad idea since the hole is oversized anyway. Well, the first side went perfect. And then, oh man. Second side, now what are we gonna do? Focus, you fuck.
Gentlemen, welcome back to the shop. Thanks for joining me here on the little baby lathe. We're going to have some fun today, what with the machining of the front platen of the flashlight project. This is going to be for the lens mounting, be all O-ring grooved up. I decided to do it on the lathe because more easy. I was going to do it on the milling machine, but more difficult. We're also going to machine the rear water cooling jacket as well as the pass-through for Z-wires. And the rear blow-off valve, the whole back of the thing is going to be a blow-off. What for not blowing your testicles up should the lithium ions decide to take a little holiday without you. Anyway, enough blabbing. Grab a beer, your favorite libation, duster, coffee, whatever. We're going to make some chips and have some laughs. And as you can see here, I'm getting used to having a crappy little DRO. Kind of like it. It is a pain in the ass because, you know, you can't really see it, but it's less of a pain in the ass than measuring everything on the piece and laying it out and yada yada yada. So, who knew? There is a use for cheap calipers. You can see there, this was not extruded. This was a plate and then shear cut, and you can see we still get some weeble wobble. So I'm just going in here just to clean it up, pretty it up. You see here we're getting some pickup from the bolt holes, chowdering up the face. So I'll use some lube, maybe change the speed a little bit, see if that helps us. Okay, way better. And we just pick up the center. We zero the DRO. Can't keep a straight face when I say that. Now we go out to 1 1/4. That's just a little shoulder there, what for picking up the OD of the lens housing. So now we're going to machine the pocket for the actual cob, the LED cob. We're going to make that, we're going to bring that out to 650 thou. After looking at this, it doesn't look right. The sizing's off. So I had a second look at it, a rookie mistake. I took the length of the sides of the square cob and took that as the diameter. On the diagonal it's a lot more than that, so we're going to cut to 830 thou. Okay, that's way more better. Focus more fucking call is the tabernacle. Has the camera chooched her last? Nope, afraid not. Now I'm going to cut the O-ring groove. We're using an 032 Buna N O-ring. Could use Viton, but just added expense. You know, if you want more better performance, then obviously you're going to upgrade to the Viton. However, this is going to be tough for me to cut this because it needs to be square shouldered. So what I'm going to attempt here is I'm going to set the tool. This is just a little super pokey bit and tool. Don't ask me what insert that is. About that size, and I'm gonna make sure that the ID shoulder is square, and then I'll sort of half-ass machine it, and we'll go ahead with the OD shoulder, change it to square, and full-ass machine it. Okay, as I was saying, and as we are all painfully aware, I'm an idiot. So yeah, that O-ring, that 031 O-ring is not going to work, so we got to go to a different size, which means I got to go to the seal catalog and figure out what size I want. Mistakes aside, that's all water under the fridge. We got her set up here. We're going to cut this O-ring groove as best we can with the tools, what we got. I'm just going to go into a bit of detail here, and a lot of machinists have already left or are laughing themselves silly at how long this has taken me. But in order to get the depth correct, what I'm doing is I just got an old crappy, doesn't even have the tip on it, just the tip mind, Mitu Toyo dial indicator, and I chooched her on the way there and zeroed it at the face, and now we'll be able to just plunge in basically, and we'll come right back around from the 0, we'll come right back around to the 50 thou. Then we know that the O-ring groove depth is correct. Okay, so now I'm happy with that shoulder, the inboard shoulder. Now we got to mess with the outboard shoulder. Ta-da! Right, that's the front side O-ring pattern done. I could measure the pass-through holes from the drawing. Simplest thing first, am I right? Just going to transfer punch all this. So what I'm going to do is transfer punch the pattern and then put a little mark here where I want the pass-through for the wires. Okay, so these got to be threaded. What for mounting that? And these got to be through holes. What for poking this? We're going to drill and tap this to machine screw 632, so we got a 36 drill bit in there. Then we're going to drill the pass-throughs that same size. I got the depth selected here. So, and the pin vise. No es bueno. The pin vise doesn't work because it goes all cattywampus on us. And the chuck I got for the R8 Bridgeport, it's 2 G's big, so I'm gonna hand drill it. Now I'm going to lay this front cob housing slash lens mounting housing. Man, shit gets complicated in a hurry. I'll lay this out for T-drilling. And that will be the exhaust for the evaporative cooling. You'll see. I'm just pulling the San Francisco typist routine here. Hunt and pecker. But for not clogging up the hole. So if I got this laid out half-assed proper, we're going to intersect this down hole with the side hole. And we're through. Everybody's happy. Yeah, there you go. Now the mermaids can swim from one plate to the other. We're just going to get centered up on my little rotary table here. This is how I half-ass it. Works pretty good. And then we're going to put this in there, center it up, drill 6 holes, what for mounting the lens. And the reason 6 is because it is not divisible by 4, and it looks good. Well, actually 5 is not divisible by 4, but you end up with a hole right in line where there's less meat, or offset, and then it looks funny. So, you know, 6 is the way to go. So we've got the rotary table centered, plus minus 5 thou, and now we're just centering the part to close as we can get it. And we'll tighten her down, drill out the pattern. Of course, 360 divided by 6 is 30 degrees. Every 60 degrees. We'll plunge a hole in there every 60 degrees, not a through hole, mind you, a blind hole. And then we'll tap it to size. Okay, we're on a bolt circle diameter from the center, of course, of 1.350. Now what we're going to do is we're going to swing this back to 0, which will bring us right dead in line with that hole, which is what we don't want. So we're going to offset 30 degrees. Now we're going to start counting, and we'll peck it. Count 60 degrees, peck it again. And because metal, it's hard to put back what you take away. It's easy to take away, but hard to fill it in. So we're going to go ahead, just use a Sharpie, what for marking it out, make sure it looks pretty. Okay, and second hole right off the bat. Look at that. Glad we tried it, because no worky. Just because it works on your head doesn't mean it works on the bench here. 6 holes is just not going to cut it. It gets all daddy. Yeah, it looks funny. So we're going to go 8 holes, and that will, 1, 2, 3, 4 divided by 8, 2. So it'll look better and it'll sync up, but it won't sync up where we need the meat, if you get what I'm driving at. There we have it. Now we can drill it to size, then we can tap it. scour out the hole, so I'm being real ginger with it. Now, once bitten, twice shy. Of course, I already broke a tap and had to digest it, which in and of itself was actually kind of fun. It's fun to discover new stuff. However, I don't want to repeat that. These taps, awesome taps. Bought them right from the source in the ROC, Republic of Korea. I was back in the early aughts when Thailand was a basket case and the economy went in the shitter. These things were so dirt cheap. I got a whole bevy of them. Never hurt me to have them sit in the toolbox. And I think this is the first time I used them. What with them being metrique and all. Okay, not T-bag. All threaded with the M4. You will note no busted taps. It's a pain in the ass to hand thread it, but it's also a more huge pain in the ass to try and extract and locate broken taps, even with the alum trick. You've already seen this, so I'm going to omit. I'm going to machine this groove here, O-ring groove for the 19 and then the 38 in the usual way, half-ass backwards. I will say the best place to go online and get info about seals or O-rings is Parker. You don't need to buy them from there. Buna and O-ring is a jelly bean part. Pretty much get that anywhere. I don't need to pay 4 times the price to get it from Fluid Seal or Parker, whatever. But do use their data sheets because they are excelente. So there's the O-ring groove there. And here's the beauty of the 4-jaw chuck. Now I got to make an O-ring around those 2 holes, so I'm going to make one O-ring groove. But the 4-jaw chuck allows me to make this as the center. That way I can cut my O-ring wherever I want. I just use the Sharpie to mark that up, and we're going to mill out the water jacket pocket. Nice little crescent there. Just doing a die run. Make sure, well, it's an idiot check, right? Wouldn't be the first time that I made a mistake. Take a nice easy cut here. See how that does. Ta-da! Well, that's the carcass of the proof of concept. All the machining done. Ooh, the fancy. Just, yeah, that lens is going to be a tough one. Difficult, technically, but we'll simplify it for the first iteration. And now all that's left to do is get some electronics in there. Mount the cob, put in some baterias, and Bob's your uncle. Hey, thanks a lot for watching. Keep your dick in a vise. Hand grinding my own lenses. It's official. Renaissance 200-pound gorilla. Ah, fire. Is there anything it can't do? Ah! I put it to you, is there anything prettier in the whole wide world than a big old piece of phosphor bronze bearing material? Now we come to it, every garage hack's favorite. Parting off. Avenge my death.